All right. So before starting a new lecture, I would like to include a few problems and solutions to things that I considered important from the previous lecture. So here we have 4 problems. First one is going to go over simplifying a circuit. Second one, graphing energy diagram from a P-curve. Third one's gonna go over solving resistance for irregular shapes. And fourth one, we're gonna go over how to use color coding table to find out the resistance of resistors. Problem 1.1, calculate voltage, current, power, and energy values for the 500 ohm resistor if a 100 volt source is connected to the circuit for 10 minutes. The reason why it says 10 minutes is because it's asking us for energy, and energy is time dependent. So we will be using this 10 minutes later in our equation. For now, this is our 500 ohm resistor. We have no information about the current going through it or the voltage across it. But we do know that we have a 100 volt source over here. And our goal here is to calculate the voltage drop percentage of this 100 volt source across our 500 ohm resistor. So to do so, I will isolate the farthest point in our circuit, which is this part, and I will try to find an equivalent resistance for all these resistors. So here I'm seeing 3 resistors in series that are parallel to our 500 ohm resistor. So that's going to be 200 plus 200 plus 100, it's 500 ohm resistors. That is parallel to another 500 ohm resistor. So the equivalent resistance is going to be 200 plus 200 plus 100 in parallel with 500. So that's going to give us 500 times 500 divided by 500 plus 500. So we're getting a 250 ohm resistor for all these 4 resistors here. That 500 ohm resistor with the series resistor across it with this 250 ohm resistor here. And still I don't have any information about the potential drop across this resistor. So what I'm gonna do is repeat the same process. So I have 3 resistors in series. It's 250 plus 250 plus 100, it's 600. That is parallel to a 200 ohm resistor. So the equivalent resistance of these 4 resistors is going to be 250 plus 250 plus 100 in parallel to 200, and that's 600 times 200 divided by 600 plus 200. That's going to give us 150 ohms resistor. So I'm going to take all these 4 resistors and I'll replace it with a 150 ohm resistor here, and still I don't have information about the voltage across it or the current through it. So we'll repeat the process one more time. So we have R equivalent is equal to 150 plus 150 in parallel to 100, and that's 300 times 100 divided by 300 plus 100, which is 75 ohms. So I'm going to replace that entire circuit now with this final circuit. Here, my 25 ohm resistor is the same one since the beginning. It has not been touched. My source as well. But then the rest of the circuit has been summarized by this equivalent resistance over here, which is a 75 ohm resistor. So now that we have this simple circuit, we can just solve for the voltage drop across this 75 ohm resistor, which represents the entire circuit except the 25 ohm. So my voltage is then going to be, from our voltage drop equation in Ohm's Law section, I know it's 100 volts times 75 ohms divided by 75 ohms plus 25 ohms. So this is 75% of the 100 volts, so that's 75 volts. So now that I have this information, I know that there is 75 volts voltage drop across the rest of my circuit. So what I'm going to do, I'm going to replace the first part of my circuit, which I know the voltage across of, with a simple battery. So this is a 75 volt battery now. Now I can analyze the rest of the circuit the same way. So what I'm interested in is the voltage through my 500 ohm, but to do so I need to know the voltage drop across the 200 ohm first. So I'm gonna still replace the rest of the circuit with the 150 ohm that we found earlier and solve for this circuit. So the voltage drop across this 150 ohm is gonna be 75 volts times 150 ohms divided by 150 plus 150. So this is half of 75, so 37.5 volts. Do the same thing. I'm gonna now replace this part with a 37.5 volt source. So now I'm interested in this voltage drop. So what I'm gonna do for a moment is replace this part with the 250 ohm again that we found earlier, and now I can find the Vx that I was looking for from the beginning. And Vx here is going to be, using voltage drop equation, 37.5 times 250 ohms divided by 250 plus 250 plus 100. And that's 41% over 37.5, which is equal to 15.625 volts. So I got my voltage information across my 500 ohm resistor. So I'm going to replace the rest of my circuit with just a 15.625 volt source. And at the end, I'm just solving for this very simple circuit. So we know we cross our 500 now, 500 ohm resistor, is equal to 15.625 volts. Using Ohm's Law, I can calculate current now. It's V over R. (15.625) divided by 500 is equal to 0.031 amps or 30 milliamps. 31 milliamps. And then my power is just V times I, which is equal to 0.49 watts. And now I'm going to be needing the 10 minutes information to calculate for my energy. So I know that for 10 minutes my power across the 500 ohm resistor has been a constant value of 0.49 watts. So for me to get the energy, all I need to do is calculate the area underneath this curve, which is the integral. So my energy, which is integral P dt from 0 to 10 minutes, just 1600 seconds, is just area of this curve, of this rectangle. So 0.49 times 600, which is equal to 293 joules. So we got all our values of power, energy, current, and voltage.